Good morning, welcome to day 34 of distance learning. The first thing that you should have done today, besides answering the attendance question, is checking the answer key in the comments that I posted on your 5.2.1 packet, which is the first packet of this new section, the second half of chapter 5. We're still kind of talking about inverses, but we're learning about something new called a logarithm. So make sure you check the answer key to this and let me know if you have any questions first. What we're going to be doing today is just notes, and then we're going to be doing practice next week. I don't want to assign you too much today. So after checking your answer key and answering the attendance question, please let me know if you have any questions on this packet. Remember, you can do corrections for full credit back. As long as it was all completed, you do get 100%. You followed all the directions, your answers make sense for the question that was asked, you do get 100%. So what I need you to do is either print out the notes that were attached to the assignment post or just write these notes on line paper in your math notebook, math binder, whatever it is that you have. And as proof that you did your work for today, you're just going to post the notes, and you only have 4 problems to do on your own. So what I'm going to do is just fill in the blanks and then obviously pause, fast forward, rewind if you're writing on line paper and you need more time to write these. So 5.2.2 logarithms and their notation notes. So I'm just going to head right into it. A logarithm is called a log for short. And it is the inverse of an exponential. And if you don't remember what an exponential is a function that has the variable is in the exponent. So right here, y equals b to the x is the parent function, like just the standard form of an exponential. So you could have like y equals 3 to the x, y equals 2 to the x, y equals 10 to the x. Those are all different exponentials. You can also have like a stretch or compression factor in the front that represents your y-intercept, like y equals 3 times 2 to the x. But we're just going to keep it simple for now. Y equals 2 to the x, 3 to the x, y equals b to the x in general. So a logarithm undoes an exponential. It's the opposite function of an exponential. I forget how long ago it was, but we had a lesson where you were asked to like find the inverse of an exponential. So what you would do is switch the x and the y. That's your first step to finding an inverse. And then we had to stop because, well, how do you get y out of the exponent? Well, now we have an operation to get it out. It's called a logarithm. So let's continue and I'll show you how. An expression in logarithmic form, such as log 232. You're going to notice that logs have a lot of different numbers, and it's because there's basically 3 values here in an exponential. So logs basically have 3 values. If this was equal to something, it would have a third value. Something like this is read as log base 2. So this 2 is small for a reason. It's a subscript, and it's the base of the log. Log base 2 of 32. So don't get confused with the 2 and the 32. The 2 is mini, and the 32 is like a regular size font 32. So log base 2 of 32. Make sure you write your subscripts, the base, as a smaller number than what you're taking the log of. To evaluate log expressions, we think of an exponent. So we kind of like can convert it back to an exponential. We can undo it. So if you have log base 2 of 32 equals 5, see there's 3 values. The reason why that is true is because you undo it, and I kind of like to call this the popcorn method because when you do the little drawing, it looks like a popcorn kernel. But you take the base, and it ends up being the base of the exponential. So 2 to the 5th. The 5 on the other side, what it's equal to is the exponent equals 32. So these two mean the same thing. It's just that I've kind of undone it so it makes sense, because this kind of looks like, what is that? But it's because 2 to the 5th is 32. So base to the exponent is equal to 32. And that's why there's 3 values. So 3 values here, 3 values here. An equation in logarithmic form is equivalent to another equation in exponential form shown below. So I'm just going to write like a random log base b of m equals y, because b to the y equals m. And that's always how you undo a log. with this little popcorn kernel thing, so b to the y equals m. Now, if you have it on the other side, like y equals log base b of m, it's still the same thing, except it doesn't look as much like a popcorn kernel because you need to go this way, so b to the y equals m. Same thing. Okay, feel free to abridge notes however you like it, but these are for you to work next week when we actually practice logs. So let's do some examples. There's rewrite each logarithmic equation as an exponential and vice versa. So if you're given a log, write it as an exponential. If you're given an exponential, write it as a log. We're going to do these two together, and I want you to do C and D on your own. And of course, you're going to upload all of this for me to check. So let's rewrite. Here in letter A, we have log base 6 of 36 equals 2. Since that's a log, we're going to write it as an exponential. So just do my popcorn. 6 squared is 36. We've undone it. We've undone the log and made it look like an exponential. So log base 6 of 36 equals 2 is written as 6 squared equals 36, which makes sense because 6 squared is 36, 6 times 6. And letter B, you're given an exponential, so you have to convert it to a log. So remember, follow the pattern up here. So our base stays the same. The base of the exponential is 64. So that's that mini subscript that goes as the base of the log. The exponent goes on the other side. It's what it's equal to. And then the 8 is the regular number that goes next to the log. I don't care if you put in parentheses. You don't need to. So 64 to the 1/2 is 8. 64 to the 1/2 is 8. Now, if you don't remember, 1/2 is the same as a square root. So anytime you have a fractional exponent, it can be the same as some sort of a root. So like 1/3 power is the cubed root, 1/4 power is the fourth root, 1/2 power is the square root. So essentially, you can write this the same as square root of 64 equals 8. But you have to remember that's the 1/2 power when you convert it to a log. Okay? So try C and D on your own. C is a logarithm like A, so I want you to do your popcorn and convert it to an exponential. And D is an exponential, and I would like you to convert it to a log, just like letter B. So now let's flip over. And of course, pause if you just wanted to do those two problems real quickly. So in 2, we're just going to find the value of x. So now we're actually going to solve. Find the value of x in each equation below. Rewrite the expression in the equivalent exponential equation to verify your answer. So right here, I have all logs. I'm going to be converting all of them to exponentials so that I can figure out what my answer is. If you notice, each of these problems has an x in it. We're going to do A, B, C, D together, and you're going to do E, F on your own. So in letter A, I have log base 4 of 64 equals x. So if I undo that with my popcorn, I'm going to convert it to an exponential. I have 4 to the x equals 64. Okay, and now you just have to figure out what x is. So if you have a calculator, I can just honestly plug in random values. So I know 4 squared is not going to work, because 4 squared is 16, so let's try 4 cubed. Remember, it's just a guessing and checking game, and don't make your numbers too big, because remember, exponentials, they rise very rapidly, so you don't want to do 4 to the 10th. Let's put 4 to the 10th. It's a very big number, so 4 cubed is 64, so I know x is 3. Because 4 cubed equals 64. I'm just going to show all my work. Okay, let's try letter B. The x is in a different spot, so it's now the subscript, it's the base. So I'm still going to do my popcorn. X cubed is 216. So I need to figure out what number cubed, what number times itself 3 times is 216. Well, again, I'm just going to take my calculator and do my guessing and checking game. You can use your phone calculator for this. You can use the Google calculator for this. But let's see. I'm going to start 2 cubed is 8, so it can't be 2. 3 cubed is 27, so it can't be 3. 4 cubed is what we just did here, so it can't be, because that's 64. We need it to be equal to 216. 5 cubed, not quite there yet, but let's see. 6 cubed. What number cubed is 216? 6. So x equals 6, because 6 cubed equals 216. 2 more. So now the x is finally in that last third spot that we haven't done yet. I'm going to do my popcorn still. So 4 squared equals x. And perhaps this is a little bit easier to think about in your head, and I kind of already just put the answer there because you just have to do 4 squared, which is 16. So x is 16 because 4 squared equals 16. One more, and this is a reminder, kind of like the fractional stuff that kind of has you, it makes you think about the solution a little bit more with the fractions, or in this case with the negative exponents. So in letter D, we have log base 3 of 1 over 243 equals x. I'm still going to popcorn. So 3 to the x is 1 over 243. So if you go from a whole number to a fraction, that means it ends up being flipped. And if you remember your exponent rules, the things that end up flipping are your negative exponents. So this is going to be a negative exponent. So what you should do, the advice I would like to give you is, I want you to figure out 3 to what power is just regular 243. And then we're just going to make it negative of whatever number we figure out. So let's just keep guessing and checking. I'm just going to do 3 to the 4th. That's 81. 3 to the 5th. Oh, already found it. So 3 to the 5th is 243. But I want 1 over 243. So that's just 3 to the negative 5th. Make it negative to flip it. So x is negative 5. So here we had a fractional exponent that is the same as a root. And here we had a negative exponent that flips. So I just want you to do E and F on your own, kind of undo it with your popcorn, convert it to an exponential, solve for x. And if you want to, you can use a calculator, but you shouldn't be rounding when you're giving me answers. These were all nice whole numbers, okay? If you have any questions on the packet or these notes, please post in the comments down below or on Google Classroom, either on the stream or on the assignment chat. And since tomorrow is a makeup day in the district, from now on, every Friday is going to be a makeup day, I would like you to enjoy your weekend. So again, let me know if you have any questions. Bye.